In this video, we're diving into one of Java's most commonly used collection classes, ArrayList. ArrayList is a class in the java.util package. You can think of an ArrayList as similar to a traditional array, but upgraded. Like arrays, an ArrayList is used to group together objects in an ordered way. ArrayLists use numeric indices starting at 0. One main difference between arrays and ArrayLists is that an ArrayList can grow or shrink dynamically as you add and remove elements. There's no need to manually resize anything or copy anything. All of the resizing is handled automatically in the background. Behind the scenes, an ArrayList is implemented with a regular array. When the ArrayList runs out of space, behind the scenes, the class creates a bigger array, moves the data over, and keeps going. But all of that happens automatically for you out of sight. This makes ArrayLists very flexible compared to arrays, which are fixed in size. The flexibility provided by ArrayLists makes it a good choice for situations when the size of your collection can change. You can create an ArrayList by specifying with generics the type of object that the ArrayList will hold and then invoking the constructor, as shown in these examples. You specify the type on the left side and either the type or just empty angle brackets on the right side. You have the option of sending in an integer to the constructor, but note that this only specifies the initial capacity of the ArrayList. It does not limit or cap how large the ArrayList can grow. ArrayLists can only hold objects, not primitives. If you want to have a list of primitives, you need to use the wrapper class, like integer instead of int, or character instead of char, capital B Boolean instead of Boolean, and so on. Make sure you use angle brackets and type on the left side, the declaration, and either angle brackets and type or just angle brackets on the right side, the initialization. Don't forget those angle brackets on the right-hand side. There are two ways to add elements to an ArrayList. The one-parameter method adds an element to the end of the list. The two-parameter method adds an item at a specific position, shifting other elements down as needed. For example, here we have an ArrayList with 3 elements. If we were to invoke the single parameter add method to add 6, 6 will be added to the end of the list. The list is now size 4. Now we have a list of size 4, and if we invoke the two parameter add method, the first parameter is the index where we want the new item to go, and the second parameter, in this case the 7, is the item that we're adding. In order to make this add, the ArrayList first shifts elements over in the list to make space for the element being added. In this case, the 6 will move over a spot, then the 3 will move to where the 6 was, the 5 will move to where the 3 was, and that leaves an empty spot where we can then add the 7. And the size of the list has now grown by 1 to size 5. Remember that in the two-parameter add method, the index comes first and the element comes second. There are also two ways to remove elements from a list. One way is to specify the element you want removed. When you use that method, the first matching element is removed from the list and the remaining elements are automatically shifted down to fill the gap. This method returns a Boolean indicating whether or not the element was found and thus removed. If you pass in a value that's not on the list, the method returns false. You can instead use the second version, which specifies the index of the element you want removed. This will also result in automatic shifting to cover up the gap to maintain the rest of the list intact. This method returns the actual object that was at that specified index. Be careful when working with numeric lists. If you pass in a primitive int, this will remove the index, the item at that index. If you want to pass the actual numeric value you want removed, you have to pass it in as an object, a capital I integer. For example, let's say we have this ArrayList here, which has 8 elements. If we want to remove the 6, the element 6, we have to pass in 6 as a capital I integer as an object. If we were to just pass in the primitive value 6, we would be saying we want to remove the element at index 6 rather than the value 6. So in order to pass in an object, we use the wrapper class to get the object version of the value we want removed. You only need to think about this when you have arrays that hold numbers. If you have an array of strings or other types of objects, this wouldn't be an issue. But in this case, if we want to pass in the object of 6, we can do so using the integer.valueOf. This will then find the value of 6, which is here at index 3, and it will shift everything down to cover up the gap that remains. So first of all, this method will return true because it found the 6, and then we'll go through and we'll shift to cover up the gap. So this 2 will move into where the 6 used to be. The 9 will move to where the 2 used to be. That second 6 will move to where the 9 was. 5 will move to where the 6 was. And now the last space in the list will be null. And the list is 1 smaller. So the list size is now 7. If we were to pass in a value that does not exist on the list, like 100 for example, this method will return false. The other version of the remove method is the one that takes in an int parameter. And again, this int indicates the index. So if we were to invoke valueList.remove 3, 3 is a primitive, we're going to remove whatever element is at index 3. So in this case, that's going to be the element of 2, and that's what's going to be returned. So we don't return a Boolean, but we return the actual object at the index that we're removing from. And then we go ahead and cover up that gap. So 9 moves into where the 2 was, 6 moves into where the 9 was, 5 moves into where the 6 was, and then in the last space, again, is a null, and the list size has been reduced by 1. Note that if you pass in an index that's not valid, this will cause a runtime error that will crash your code. So if we were to invoke valueList.remove 8, for example, which is not a valid index for our list, we'll get a runtime error and the code will crash. The get method allows you to access elements in an array. You pass in the index, and the method returns the object at that index. Similar to the remove method that takes an index, if you pass an invalid index, this will cause a runtime error that will crash your code. There are many other helpful methods you can use with ArrayLists, and here's just a couple of them. The set method replaces an item at a specified index with a new element that you pass in. The old element is returned from the method. The contains method checks to see if an item is on the list. The index of and last index of methods find the first or last index of a specific item. If the item's not on the list, then -1 is returned. Size tells you how many elements are on the list. Is empty checks to see if the list is empty. And clear will remove all elements from the list. As a reminder, remember that if you pass in an invalid index to the get, set, or remove method, that will not be a compile time error. It will unfortunately cause a runtime crash. You can loop through an array with a traditional for loop or with the enhanced for each loop. Remember for traditional for loops, and for any other time you use an index in invoking any ArrayList methods, that the valid indices go from 0 up to list.size -1. That'll be the largest valid index. And again, you can use a traditional for loop or the enhanced for each loop. The for each loop is preferred when possible if, for example, you don't need to access the actual loop index for any reason. Here's an example of iterating a number list with a for loop, traditional for loop, and printing out whether each number is odd. Because we're printing the index in this code, we need to use the traditional for loop, so we have access to that index number. Here's another example where we're changing elements of the list with the set method. Because again, the set method needs an index, we need to use a traditional for loop, so we have access to that index. Here's an example where we're just accessing each element in the list. In this case, we're printing an uppercase version of each word in the list. Since the index of the list doesn't matter, it's best practice to use the enhanced for loop, or for each loop in this case. In general, if all you need to do is invoke some method on each element in the list, or check each element for some characteristic, or using a for each is preferred. Basically, anytime you don't need the actual numeric index to accomplish your task, it's better to use a for each. So ArrayLists seem pretty great, and they are. This might make you wonder why you still need to know about arrays at all. Well, arrays are common across most programming languages, not just Java, so it's important to understand what they are and how they work as part of your general knowledge as a programmer. In Java specifically, arrays can be used to store objects or primitives, whereas ArrayLists can only store objects. Arrays are also more efficient because they don't have the overhead associated with an ArrayList being a class. And in fact, remember that behind the scenes, ArrayLists are actually built on and implemented with arrays. So that's another reason it's important to know about arrays, because it can help you understand how ArrayLists works. Arrays and ArrayLists have lots in common. They both allow you to store an ordered collection of items. In addition, the actual variable itself, the array or the ArrayList, is an object in both cases. Both arrays and ArrayLists start their collections at index 0. And for both arrays and ArrayLists, trying to access an index that's out of bounds will cause a runtime crash. Of course, there are differences between arrays and ArrayLists too. Arrays are built into the Java language, while ArrayLists are a class. Arrays can hold primitives or objects, and ArrayLists can only hold objects. One major difference is that you need to directly write code to manipulate an array. For example, to remove an element from the middle, you'd have to write the shifting code yourself. ArrayLists, on the other hand, come with a very large collection of user-friendly methods that allow you to manage and manipulate the elements in many different ways. This is a big advantage of using ArrayLists. Arrays are fixed in size. Once you declare an array, you cannot change its size, but ArrayLists will grow and shrink as needed. This is another important advantage of using ArrayLists, especially when you're in a situation where the size of your dataset might change. With an array, accessing .length will tell you what the capacity of the array is, but there's no automated way to tell how many elements have actually been added or stored in the array. Because of this, there's no way to know where the last added element is. With an ArrayList, invoking the .size method will give you the current number of elements stored in the list, and that means the last element is always going to be at index.size minus 1. You'll use both arrays and ArrayLists often. It's always good to think about whether an array or an ArrayList is the best tool for the job. ArrayLists are a convenient and powerful way to hold groups of elements, and you can now have both arrays and the ArrayList class as possible tools in your toolbox of Java programming.